So hello everyone, and thank you for joining us today for our safety webinar on using lift points, understanding proper use of eye bolts, swivel hoist rings, and clamps. In lifting applications, the need may arise to attach lift points to a load. How the lift points are attached can have a significant effect on the sling, the rigging hardware, and the load itself. In this webinar, we will review some common items used as lift points, including eye bolts, swivel hoist rings, and clamps, and discuss when and how to use them safely and effectively. Presenting today will be Peter Cook, Training Manager at Columbus McKinnon. Peter started our hands-on training program from our original CM factory in Tonawanda, New York, and encouraged certification for rigging and cranes. He helped NCCCO and CIC develop certification for riggers. Peter has also been involved with ASME B30.9 to help write sling safety standards. So as I think you can see, he's got quite a bit of knowledge on this topic. My name is Gisela Clark. I'm the e-marketing specialist at Columbus McKinnon and will be your host for today's webinar. Before we begin, there are just a few things we'd like to cover. First of all, we are recording the session today, and the recording link will be added to our YouTube channel. All in attendance will receive a link to the recording. Second, everyone is in listen-only mode, so we encourage you to ask questions in the Q&A pane on the right side of your page. We'll take 5 minutes at the end to answer your questions. I noticed that no one has commented or made any questions. If someone could quick, I would appreciate it. Just give me where you are today, just so I know that it's working, because by now I usually have received some comments from some people. I want to make sure everything is properly enabled. Yes, perfect. Thank you for that. And lastly, after each webinar, we will select one of the questions that one of you asked in this series session today, and we will use it in our blog the following week. And if your question is the one chosen, we'll send you a Columbus McKinnon promotional item, something cool like a CMCO polo shirt, hat, work gloves, glasses, something like that. We just featured our last webinar, we had 2 questions that were asked, and we featured them over the last month on our blog. So we encourage you to ask the questions, and we'd love to feature you on our blog in the next week or 2. So thank you for your attention. Now I'd like to turn the meeting over to Peter so that we can begin. Thank you.
Thank you, Gisela, and everybody, thank you for joining us. So today's topics: safe use of eye bolts, swivel hoist rings, and understanding how plate clamps work. Those are some 3 common items that can be used for lift points and materials, and we're going to go over the do's and don'ts with them and what exactly it can do. As always, this is not a substitute for any manufacturer's information or any OSHA or ASME or safety standard guidelines, so we encourage you to seek out those regulations, laws, and manufacturer's recommendations before using any product and be properly trained on that. And any questions should be referred to the cited regulations and consult with an attorney. So let's start off. Let's talk about eye bolts and swivel hoist rings. Okay, and this is right from the CM Rigging Pocket Guide, which is available to anybody that wants one. So eye bolts. One of the things with eye bolts here, and you can see, is they lose working load limit if you don't lift straight up vertical. So when you're looking at eye bolt charts, you'll see that it has a true vertical lift. Okay, that's where you're going to get your if it's installed right, that's where you're going to get your maximum working load limit. Okay, a little bit different from rigging if you're used to rigging at angles where slings and things of that nature, we take the angle from the horizontal, and in this chart, you can see the angle there is taken from vertical. So just at 75 degrees side load, we're going to get only 55% of its full rated load. So that's pretty dramatic. It's not too far off, right, from vertical, but that is very dramatic. So riggers need to really understand when they're using eye bolts how drastically these drop. And again, that's if it's installed right. At 65 degrees, you're at 35% of the full work moment. 45 degrees, 25% of the full work moment. Columbus McKinnon never recommends going less than 45 degrees in use of an eye bolt. So there you can see dramatic working limits. And usually on the eye bolt itself, you very rarely find the working limit. Some do, some don't. What they'll either have is a pattern size or a number that you have to go and you have to reference. It may have the diameter size of the bolt thread. So you have to go reference the rigging charts to see what you can do with that eye bolt. And because of the drastic work limits, they don't put a lot of manufacturers won't put the working load limit on there, so they want you to reference the charts to do that. So a rigger needs to know that that's what they have to do, is go reference charts when using these eye bolts. So the slide to the right, you can see what it is. What this will explain is the proper engagement for an eye bolt, and also has a swivel hoist ring, which is similar to an eye bolt, but a much better quality than an eye bolt. But you can see there that your thread hole needs to be 1.5 times the diameter of the thread size for engagement, and then that shoulder should be fully seated. Now there's shoulderless eye bolts and there's shouldered eye bolts. So shoulderless eye bolts, if they don't have a shoulder, can only be used for vertical lift. So you see on the very bottom on the right hand side, the very bottom there, it says side loading. It says there's a non-shouldered eye bolt. That's only vertical lift, and you have to have the right thread engagement there. Okay. And the middle section there, it says always pull load in the plane of the eye. So how your eye bolt bottoms out on your object, you want to be sure that it orientates into the line of tension properly. So if you're lifting vertically, that might not be, it doesn't really matter, right? Because you can lift vertical, so you don't have to worry about where it bottoms out on your load. But if you're connecting slings, the eye needs to line up with the line of tension. So you have to turn it into the line of tension. So you can see they're the correct position. And then in the red arrow, if your line of tension was going in that direction perpendicular, you'll end up bending the eye bolt, and it's a dangerous situation to rig in that manner. So you're allowed one washer of various thickness to get that eye into the right orientation. So obviously the thickness will play a role in where it bottoms out and where you can turn it into the right position. So that is allowed you to do that. Again, you still have to maintain that 1.5 times thread engagement, so that's important. One thing we always recommend is that you connect a shackle to an eye bolt, and then connect your slings to the shackle or your hooks to the shackle. Never directly connect to an eye bolt. That can be put undue side loading that's unanticipated, that you don't think is going on. You can have some binding going on there, or someone may try to choke into the eye, which is not a good idea. And then once you use a shackle, make sure your shackle is orientated right, that it seats properly when you're rigging, because you can see that if it kind of goes off at an angle a little bit, we don't want that. We don't want to put any undue stress on the eye bolt that we don't need. So a couple examples here of incorrect use. You can see there if you have a sloped surface there, that's not a good situation to have an eye bolt. That you would want a special wedge type washer. There's a name for that washer, I always forget the name of it, but you want to shore that up, make sure that doesn't happen. Again, that could bend the threads and damage the eye bolt. So you want, again, the shoulder has to be fully seated. That's the rule to using eye bolts. That shoulder needs to be fully seated. And again, using it at an angle, you can see there's the shackles there. And if you remember from our charts, at a 45-degree angle, if I was going to lift a load, I'm going to just go back a minute. At 45 degrees, you're only at 25% of the working load limit. So that's you have to take your proper reductions to whatever you're using there. Okay? So these two, I'm just kind of flip back and forth. This here, for an untrained rigger, that would almost seem the same way, where someone would actually loop their slings to the eye bolt. So in this case, they don't have connection hardware like a shackle. And so what they decide to do is loop their sling through the eye bolt and make this kind of connection, which doesn't look that much different, but that changes the whole ball game, and that puts a tremendous amount of tension on your sling, and also compressive forces on your load, and also extreme side load of your eye bolts that you haven't anticipated. So that's an incorrect way to rig with an eye bolt, which is commonly done when the right hardware is not available. So what I find is people will use what's available to them, and if it's not available, they have to make the lift, and they end up doing something wrong, and thus putting themselves in danger. So you have to make sure you have a variety of items on hand, and you understand how you're going to connect the things so that you have the right equipment on hand.
Hey, Peter, really quick, a couple have said it's called a bevel washer. Is that correct? Bevel washer? Yep. Okay, great. Bevel Thank you. Two people chimed in.
Yeah, I always forget the name of it, but it's commonly used in, crane builders commonly use them.
Gotcha. Thank you both.
Thank you for that. Yeah, certain things, my mind just, I don't know, it goes blank all the time. Like, there's a name for that.
Yeah.
Um,
Well, it shows that they're paying attention, which is always a good
that's good. That's good.
Thank you.
That was my whole intention. Make some
Of
interactiveness.
course.
All right. So here we go. Here's some pictures. In the first picture there, you can see there is a shackle attached to the eyebolt, and then they loop their chain through the shackle. And that's correct, but we have to be sure that we take the correct D to D ratio of the chain. So in the ASME B9 and the manufacturer's information, also in NACM information, the National Association of Chain Manufacturers, they have come out and published D to D ratios, which in a nutshell says that if you don't have whatever your chain is looping around, so the diameter of the chain itself, the physical link diameter itself, has to be 6 times the diameter of what it's going around. And if it's not, then you have to reduce the work limits of your chain. So, you think about that. So there's another reduction in work limit. So you have your eye bolt, you're lifting at your eye bolt at an angle, you have to take your eye bolt reduction, then you go loop your chain through the shackle, and now I got to worry about chain reductions and things of that nature. So you got to be careful what hitch you use and how, making sure you're taking all your proper reductions. Here you can see a hook. This is how we would connect a hook to an eye bolt. Again, a shackle, a hook, that's a great connection. And then here's what someone may do that if they don't have connecting hardware, they would choke their sling within the eye, and that just pretty much creates a knot in the sling, which is going to weaken the sling severely, and so that is not a good situation to have doing that. And then the last there would be the right connection for a synthetic sling and a shackle placed into an eye bolt. Okay, so you always make sure you do the right connections. Here, if the eye bolt is not seated properly, you can see that if it's non-shouldered, that it's going to bend over and possibly break. And so now I'm going to talk about getting into swivel hoist rings, which, in my opinion, are much better than an eye bolt. They articulate into the correct orientation for the line of tension, and they do not lose any working load limit. Right? So a much safer application, in my opinion. If you have the means, I would highly recommend going to swivel hoist rings for your applications.
Oh, really quick, Peter, I have a question. A lot of industrial motors come from the manufacturer with an eye bolt installed. Would you recommend, based on your last comment, a swivel hoist ring take its place?
Yeah, that's a good question, and yeah, that is true. Most motor manufacturers, all right, their job is to make motors, and eye bolts are relatively cheap, so they use cheap in cost is what I mean, and so they use the eye bolts to move their motors around the factory to get them shipped to the customer. Okay, and so how the customer's going to use that motor and how they rig it and place it and orientate it, right? That eye bolt can become dangerous when it's still attached to the motor. I was at a company that makes a lot of paper products and doing a rigging class, and the guy that ran the motor shop, very large industrial motors, and said, "Can you come to my shop after this?" And sure enough, he showed me that all the eye bolts that were bent, snapped off these big industrial motors because the way they have to orientate and get them into their machines, it's not always just straight up and straight down. They get placed nicely. They have to sometimes rock it or rotate it in there, depending on what interferences they have. And they've had a lot of drops and accidents, and now in the process of switching over to all swivel hoist rings for doing that, and even in some cases totally side loading eye bolts when the orientation. Yeah, so it became a really dangerous situation for them, and they're switching over to swivel hoist rings. Thus, and they weren't trained on the nuances of eye bolts. What you need to do in order to use them correctly. They weren't properly trained on that. So the swivel hoist ring, all right, is a lot more forgiving, right? It will orientate itself right. It won't lose work limit. You still need that thread engagement, though, and it still needs to be seated down, but you don't have to use washers or anything underneath it. And so it's a much more safe product to have. So let's get into swivel hoist rings. So there you can see an application where if you had an eye bolt in that application, you would totally side load the eye bolt, which is not a good situation. So the swivel hoist ring articulates into the one. You got a side load, and then also you have angular loading all going on at the same time, so it gets kind of complex. So all you really need to know in that situation is what's my line tension coming in. So we show people how to calculate line tensions in rigging classes. So if you calculate your tension, great. What's my tension? Then you size your swivel hoist ring accordingly, or you verify that your swivel hoist ring can handle that tension. The only drawback to a swivel hoist ring, you have to make sure that there's no binding at all, the where, how, and how you attach it. So it has to be able, once installed, it should rotate 360, or it must rotate 360 and pivot 180, and there should be no binding at all when you're going to make a lift. Again, swivel hoisting still need the 1.5 times the bolt engagement, right? But the swivel hoisting will also give you a torque spec, so those have to be torqued down. So on the ring, on top of the swivel hoisting, there'll be a special washer that tells you the working load, the torque that you need to tighten it down to. And then also, even with eye bolts, we want to make sure that the strength of the material is adequate enough that you're not going to pull the threads right out of the material, because basically what we're getting at is soft material. So we want to be sure that, you know, when we suspect that the material is soft, and we want to consult the manufacturer and say, okay, here's the material I have. What do you recommend and how I connect to this? And they will have recommendations for you on how to do that. Or they may have a calculation you can do to reduce the capacity as well, and say, okay, even though that is rated for this, you're using a soft material, we're going to have to downrate it, and that's what you want to consult a manufacturer for. As with any rigging, we always want to avoid any type of shock loads. We always want to lift gradually. We always want to evaluate our rigging before the load leaves the ground. So get it taut before the load leaves, and just kind of evaluate everything. And did it render the way I want it to? Is everything seated properly? Anytime you look at something in rigging and you're kind of hemming and hawing, or you say, boy, that doesn't look right, or it kind of looks ugly, it probably is wrong. And so you should reevaluate, and then maybe even contact or get in touch with somebody that may know a little bit more than that particular rigger. So really what OSHA and ASME want to see, they want trained riggers. And just because maybe a rigger has certification or you know, has years of experience, what they want is that person to take a step back, understand, hey, they may not have all the answers, but they should be able to recognize something's wrong, and to go seek help, to get a more qualified person, or maybe, you know, and they maybe have done that lift before, and say, hey, this is the solution for this. And that's what we need to do in this industry, is have a go-to person and say, hey, what do you think of this, and how can I do it better?
Excellent.
Some examples of, you know, when you have some binding that could break the swivel hoist ring. So if it can't rotate 360 or it binds, again, all bets are off. You're going to have some damage, or you can possibly lose that load. So you always got to make sure the loading remains in line.
Peter, can I do a quick polling question?
Sure.
Great. Hang on 1 second. Okay, the question is, how much thread engagement is needed on eye bolts or swivel hoist rings? Is it 1 1/4 times thread diameter, 1 1/2, 2 times, or none of the above? Okay, well, wait, again, how much thread engagement is needed on eye bolts or swivel hoist rings? Is it 1 1/4, 1 1/2, or 2 times thread diameter, or none of the above? We'll give it another couple seconds. If you're on an iPad, unfortunately, you won't be able to vote. So you could ping me your answer in the Q&A pane. That looks like someone already has. Yeah, 1 1/2. Thank you, Steve. Quick to respond. It looks like, Peter, 91% say 1 1/2 and 10% say 2 times. Or actually 92% and 8%. What is the answer?
1 1/2 times the thread diameter is the exact thread engagement that you need to properly secure a swivel hoist ring or eye bolt.
Excellent. Thank you.
Okay. All right. So let's talk about plate clamps for a little bit. And so there may be a time where, hey, there's some certain objects that I can't drill a hole in it, I can't get it threaded, that's going to ruin what I'm trying to do. So if the application fits, you could use a plate clamp, which is another means of basically a lift point. You're making a lift point on there. Okay. So plate clamps, again, if you know what you're doing, they're very safe. So you have to be trained in the use of plate clamps, all right? And what I tell a lot of people is you just cannot have one plate clamp that's going to handle all your lifts for you. You're going to need, depending on the nature and how many different types of lifts you may need a dozen of them. Put it this way, if you handed me an adjustable wrench and said, well, it's an adjustable wrench, that's all you're going to need to work on the engine of your car. Yeah, probably not, right? Because there's going to be certain things where that adjustable wrench isn't going to fit, or it's just going to be too cumbersome to use, or it's just not right for the job, or I might do things improper by stripping nuts and bolts. So again, you want different tools for the job, and these are tools, right? So we just can't have one tool, and that's a common mistake where, oh, it's going to fit all, it's going to lift everything for me. I have the plate clamp. So that's a common mistake that's used. You need a variety of stuff to choose from, and I'm going to get into that in a little bit. Okay, so how does a plate clamp work? And the best way I can describe it in layman's terms is, you ever seen those finger handcuffs where you put your fingers in both sides, and the harder you pull on it, the less likely you're getting your fingers out of there. And then the lighter you pull, that's how your fingers slip out. So clamps work in the same way. The more weight I have, the tighter the grip. The less weight I have, the less grip. So light loads can be an issue for a clamp, and we're going to talk about that. So basically what happens is we have teeth in the clamp. Those teeth push into the plate, okay? And so thus now that's basically how it secures itself to the plate. And the plate's center of gravity will always be below the lifting point in this case. So that's how we want to attach them if we're using a single clamp. If you can see, what we utilize here is a sloping slot for our design, and that creates tension. So that tension we use to our advantage, which rotates the jaw here and creates the cam action that gives us the pressure to push into the plate. So again, the lighter the pressure, the lighter the penetration of the teeth into the plate. Okay? So we have a load, causes link tension, causes jaw torque, causes grip. The weaker the grip, the less penetration. So we need minimum load requirements. And when I first started off with plate clamps, we didn't do this at the time, about 10 years ago, but no manufacturer did. But we instituted a 20% rule. And what that said was you only can lift as light as 20% of the maximum working limit. And why we did that, for ease of use in the field. So if I had a clamp that was rated for 2,000 pounds, I would drop a 0 off the end, times it by 2, and I could say, okay, 400 pounds is the minimum load I can lift with that particular clamp. So it was easy to calculate in the field and figure out. Nowadays, we are stamping min and max loading on the clamp, and it's in our charts and things of that nature. Again, a clamp that is lifting 2,000 pounds is more efficient. You have higher penetration of your teeth than a clamp that's only lifting 400, right? Because it can't go in as far. And so we have to watch wear when we're lifting those light loads. We really got to understand the wear criteria, and if we're seeing wear, because it's just not going to push in as far. So you have minimal wear allowed when you're lifting light loads because of the tooth penetration. So here's kind of an exaggerated picture or a blown up view. You can see at full load you get all this tooth penetration there, and you can see the penetration distance there. But what if the penetration distance was a lot less, right? And that particular distance wore right off. And if I don't have enough weight, then it won't go in any further. So that's why you can see light loads that are slipped. So ideally, when you're selecting a plate clamp, and what I'm getting at of all this is you want to choose a clamp that is pretty much right at the weight that you're lifting. Ideally, if you can grab it, so if I'm lifting 1,500 pounds, I want a clamp with a working load limit right around 1,500 pounds. Then I know I can push those teeth in as far as they can possibly go, and I'm getting the most efficiency out of that clamp. So if I have a light load, I want to try to grab a clamp that is more towards the lighter end of the spectrum. So that's now you see what I'm getting at is why you need all these different types of clamps within your rigging paraphernalia or rigging hardware selection for your people to choose from. Same thing with the mouth width. You might have a clamp that we could have a clamps that have real wide mouths on them, and you're like, well, I'm still within that working load limit, or I'm near the capacity of the clamp, and that's a good thing. Well, if the clamp is too wide for a particular plate, well, that plate can rotate inside the clamp. So the other aspect of that is we want to try to get that mouth opening as close as possible to the width of the plate we're lifting. So all those things come into play. Now that can't always be the case, but that would just be like the ideal perfect use of a clamp where the mouth is the maximum width of the clamp can handle, and the work load limit is the maximum work load limit the clamp can handle. If all those things align, you would have the proper application of a clamp each and every time. But that's not always possible. So we have minimum loads, and the operator has to watch how his plate's reacting in there. I just had a customer the other day where that just happened to them, where the plate was rotating within the clamp, and the operator, it's kind of scared the operator. It's a pretty heavy plate. I believe it was a 30,000-pound plate. They're using quite a big plate clamp. So you can naturally, the crane operator is very concerned while he's lifting that load. So any little thing that he sees, and that's a very good crane operator, he's questioning, hey, I don't feel comfortable around this when I see that plate do that or rock in there and do that. And really what they needed was another clamp with a more narrow throat, so that reaction couldn't happen, and thus you get a tighter grip. And that was the solution to that problem. Okay.
Peter, a couple quick questions. I know you're in the middle of it, but I thought these would be kind of relevant. First off, how often should plate clamps be inspected by a competent person?
Well, I would say each and every use. By the rigger should be that competent person. So I would say that they should be inspecting them just about every lift, looking at their teeth. It doesn't take more than 30 seconds to look at the teeth, make sure the teeth are clean, they're not chipped, they're not blunt. Understand where the clamp is going to bite the plate in certain positions. So I would say the rigger should be qualified. They might not have to do a written report or anything like that,
Okay.
but they should understand that it starts with them first. Now, if you want to have someone who's efficient, depending on how to use, monthly to every 3 months, to be looking at making sure that if you have a qualified inspector, if that's what you're getting at, then you want to have that person monthly to every 3 months looking at the teeth of those clamps.
Okay, and then another question, is there a maximum tooth wear, like 10% or?
Oh, the tooth wear? Each clamp will come with, that's a very good question, and that each clamp is going to come with a criteria of the tooth wear. On small clamps, it's going to be tough to see. You're going to have to really keep an eye on it. Bigger clamps, you'll be able to see the wear more readily. But each clamp is going to come with a set criteria of how much wear is allowed when you get those clamps.
Okay, perfect. Thank you.
One of the things is friction. Wear is wear is probably the biggest enemy of a clamp. We want to try to eliminate as much wear as we can, and so we have to minimize how much the tooth goes into the plate because of wear issues. And so we got to watch the tooth profile and design. This gets a little bit more into the design of it, but definitely wear is an issue. And so you see the wear as a blunting of a jaw. The style of clamps that we use has this little wear indicator that kind of gives you a visual. So we put this line in there, and you can kind of see in between the teeth. That's kind of a visual you can kind of see, and so you look at that because that piece would never wear, so you can kind of see how close you're getting in certain areas, because you always have teeth that are not in use or very rarely get used. So you can what you can do is you can compare those good teeth with the area that you're using and say, oh wow, then you can kind of see the wear. So that's what we call a wear indicator, so you can keep an eye on it. We have to worry about plate hardness, plate thickness. The plate hardness, obviously, most clamps are 300 Bernal, so we don't want to lift a plate that's harder than that. If we have to, then we have to go into a higher grip type clamp or a non-marring type clamp. And again, weight of the load, how the clamp is fitted, things of that nature. So there is some really proper training that needs to go on. If anyone in your companies are using clamps, that they get trained properly on there. So again, we talked about wear. So how do we eliminate wear? Well, obviously wear happens when there's surfaces touch or the surfaces are under load and they have movement. All that's going to cause wear. So things that eliminate wear, a lubrication, right, or minimizing the load. So we can't lubricate, right? That's not, we're gripping a plate, so the lubrication is out. We need load, we're got to lift. That's the whole purpose of the clamp, is to move a load, move weight. So what we do is we minimize the movement. And how do we minimize movement? By clamping tighter and training the crane operator. Do not let those plates swing. Nice, methodical, slow movement of those clamps. If you ever seen, I've seen people who've been untrained and go too fast with these clamps, and you have this clock type motion that are swinging back and forth. And when you start that load swing, all that's doing is grinding those teeth, and that is not a good situation. So the key is to grip as tight as you can. Again, everything I talked about at the beginning about clamps is you want that tight grip, meaning I want to try to select a clamp near the weight of the load that I'm lifting. The work load of the clamp should be near the weight of the load that I'm lifting. That's how you get the tight grip, and that's how you minimize movement, and that's how you minimize wear. Okay? So wear reduces tooth penetration. You can see there, your penetration distance goes slower. So what happens? A lot of times what will happen is I'll get calls sometimes, and someone will say, hey, I was lifting a plate to work good for a month, and then it suddenly dropped the load. And basically, then I figure out, oh, they got a 3-ton clamp, and they were trying to use it to lift 300 pounds, and it didn't. After the wear, because that tooth profile of that huge clamp is so big that for the light loads, it really just can't push it in. There's too much surface area. So that little wear, it worked at first, and then that little wear happened that was actually biting the plate is now gone, and so the load will slip out. Okay, so use a clamp with the closest work length to the weight of the plate we're being lifting. The jaw will give the max clamping force and penetration. Use a clamp with a max jaw capacity at close to material thickness. Spring will be stretched to the maximum for initial grip. Fit the clamp properly, and minimize moving during the lift. So a good crane operator will do it. So if you stick to that criteria, you will always have great success with plate clamps and using it safely and be most efficient. Okay.
Really quick, Peter, before you continue, I noticed 2 of our participants have raised their hands.
Sure.
Since we're not able to let them talk, it's Richard and Robert. If the 2 of you have a question, please type it in, and I'll be sure to get it. Because as I said, we're not able to unmute everyone to be able to hear you ask your question. So please type it in, and we'll take it. Go ahead, Peter. Thanks.
Okay. All right. So here's a long plate, and someone's using 2 clamps. Obviously, if you have long plates, 1 clamp is just not going to work. It's going to be too unstable. So you go to 2 long plates. If the clamp doesn't have a hinge, I have to use a spreader bar with 2 chain drops down on there. I do not want to side load those clamps. And then I got to watch again the minimum weight when I use 2 clamps, because I'm splitting the weight between the 2 clamps now. So I have to watch that. So that's a correct application there with the clamp without a hinge. And then here we talk about fitting the clamp properly. So you can see here's a clamp with, when you fit it, there's no gap. Whenever possible, plates should be stored and worked with their edges are in line with the crane axis. So what does that mean? You see on the bottom of the page it says crane axis. So whether that's north, south, east, west, that's in line with the axis of the crane versus if it was like kind of turned a little bit. And now that makes it difficult for the crane operator, because not only does he have to trolley and bridge at the same time, and that can cause erratic movements of the plate. So you want to make sure you set up your plates within the crane axis. I always recommend when doing a plate flip, maybe even try to set your plate up that is perpendicular. The flip would be perpendicular to the drum and not running parallel, because we don't want to side load our drum, and in the event the operator is not watching the ropes on the crane, they could drag the ropes across the drum. So you want to be, the flip be perpendicular to the drum instead of parallel with it. So that, just little things and you can do parallel, but it's just the crane operator has to be right on. You can see where you stand. What I would do actually is stand off to the side a little bit from that clamp. I know this slide doesn't really show it, but in the event something happened where you didn't install it right, or maybe you forgot to lock the lever or something, and that clamp were to kick out, you just want to stand a little bit away from it to the right or the left, so that if it ever kicked out, you're not standing there. But that's a safe place to stand at the start of the lift. Okay, you can see you need some wood spacers and things underneath it. And then as you do your lift, you want to change your location, and you want to go to the side edge of it. And so you're going there, and that's in a good place to stand near the side, because you're putting yourself out of danger now. So if the plate were to fall, it's going to fall back towards where it originally was or the other way. Okay, and then we get to a position, the top dead center position. It's a real small position where the clamp is, or where the weight. Let me reset. The top dead center position is a place where we actually see zero loading. It's kind of where the plate is in equilibrium with the ground. So it's kind of its balance point, if you will. It's a real small area that the crane operator has to quickly get through that area. It's a very small area. but you have to watch and make sure that's just about when the plate's about to leave the ground. We want to get that off the ground at that point, and not maybe, we try to tell operators, don't stop once you're at that position. Just keep going with your lift. Or don't, let's say it's the fabrication and they want to stop there for fabrication reasons. No, that's not, then what that happens is now you have no load, and so you have the wrong device for that job. So if you wanted to lift the plate to a certain position, and then you're like, let's say a welder is going to come in and start welding, you do not want to have that plate clamp on there because you have no load and it could slip off. So in that case, we end up going with screw type clamps that we actually use, that it's not for non-lifting but more for holding into position. So you don't ever want to have a clamp being used to hold something into position because there's no loading on it. Okay, so get over through that danger zone and get that plate off the ground. And once you lift, if the balance point exceeds a 15 degree from being level, then you probably didn't put your clamp in the right position. So you didn't have it center, or maybe it's a plate that was on a burn table and shapes were taken out of it, and you thought you knew where the center of gravity was, and when you went to lift it, nope, you're off a little bit, and you have to readjust that clamp. So then before you go and travel that plate, you're going to have to set it back down and re-rig it and start all over again. Okay, so that concludes some of the things that I want to talk about in lift points, and we'll open this up to any questions and answers.
Okay, before we do that, go ahead and type in your questions. We'd love to take them. I want to do one more polling question. I lost the page numbers towards the end, and I didn't want to disrupt Peter. So really quick, what is the minimum weight that can be lifted with a vertical plate clamp? Is it 10% of the working load, 20%, or 25% of the working load, or does weight have no effect? Again, let me just see this quick. What is the minimum weight that can be lifted? Is it 10, 20, 25%, or does weight have no effect? Okay, it looks like we have a whole wide range of answers, Peter. About, let's see, 2% think answer 1, 75% think 20%, 13% think 25% of the working load, and about 8% say weight has no effect. So what is the answer, Peter?
You want the minimum load you can have with the clamp is 20% of the load working limit. So that's why I talked about if your clamp doesn't have a min and max loading stamped on it, that you just take the maximum working load limit, it says, drop a 0 off the end of it and times it by 2, and that will give you your 20% or your minimum loading.
Perfect. Excellent. Thank you. All right. So we do have some questions that have come in. Let me just expand this out. Hang on. All right. The first one is, I'm an entertainment rigger. While I'm gaining knowledge here, we would benefit from a lift point webinar that covers eye bolts and swivel rings coupled with slings and beam clamps. So that's very good feedback. While I'm certified through ETCP, I attend these to learn and gain renewal points. Okay, very good feedback. That's something.
Yeah, we were just staying a little bit on the basic side, but sure, we could talk about tensions and the basic. I think that's what they mean. If I have the tensions coming in and how that affects the working load limit. So that would be more of a tension calculations webinar that we could do.
But that's great, because we would love to have one maybe focused more at entertainment. So thank you for that, Robert. We appreciate it. Appreciate the feedback. Okay, how is the resultant load determined? Let's see. The slideshow for reeving was at 45 degrees with a 1.84 resultant. How would the math work for a 30 degree?
Well, that was just kind of showing that we don't want that type of rigging. But what you can do if you want to calculate what your tension is, so you don't want to rig that way where it's reeved through the eye bolt. So if you're at a 30 degree, your tension factor is 2 times the share of load that you're lifting. So for instance, if I was lifting a 10,000 pound plate and I place my eye bolts on either side of the center of gravity at a certain distance, whatever, and that means I have 5,000 pounds of load. If I lift vertically on each with the scale on each of those eye bolts, it would show me 5,000 pounds. So my share of load is 5,000, and if I rigged at a 30, my tension would be 10,000 pounds. So I would have to make sure that eye bolt would have to take 10,000 pounds of tension. However, if you remember from the slide, we do not recommend going below a 45-degree angle with an eye bolt. And so that's where you want to change to a swivel hoist ring in that instance. And then you would try, and that, for the example I just talked about, you would choose a swivel hoist ring that can handle 10,000 pounds of tension.
Okay, perfect. Thank you. The next question, you mentioned screw type clamps to hold plates in vertical position. I'm not familiar with that type of lifter. Do you have information, pictures of that lifter that I could show my customer?
Sure, it's not a lift. Yeah, the screw type clamp is not a lifting device. We call them pulling clamps. So you're basically, it's for the application I described, where you're maybe lifting a plate up, but it's not going to leave the ground, which means you're going to hold it into position for fabrication means, such as shipbuilding, things of that nature. And so those clamps don't need gravity. However, if you were to transport that clamp, say, okay, well, you're going to use a screw type clamp and then you use it to lift them, then you have the wrong application. So when I talked on that application I talked about was more for fabrication means, where you're not actually lifting the plate, but you're just putting it into position. Then you need the screw type or pulling type clamp that basically is like a vise that you would grip on there. But we do not recommend those types of clamps for overhead lifting.
Okay.
But yes, we can get information on that.
Okay. I have his information. Peter can follow up with you on that. Okay, no problem. Next question: do lifting clamps and other rigging gear require periodic load testing?
No. We test all our equipment at the factory. The only time for lifting clamps where you would have to have load testing is if you replace the load-bearing component on there. So if you replace the jaws or the lift ring or anything that bears the load. Basically, I would recommend a load test anytime you replace a component on a clamp. But other than that, if you have a clamp that there's nothing wrong with it, it passes your periodic inspection, and you can continue to use it indefinitely without having to do another load test. And until you now, I want to back up a little bit. For those of you that do testing on your equipment, I wouldn't recommend. That's great. You're exceeding the any applicable standard manufacturer's recommendations. So you're actually doing better than what you tell. You're being more safe and proactive. So I encourage that. But there is nothing that states that you have to do load tests after the manufacturer's load test.
Okay. Great, thanks. Quick question or quick comment. Troy Rains just wanted to say, Peter, to a previous question, that it's a positioning clamp and it's great for assembling weldments.
Yeah, positioning clamp, holding clamp. Yeah, there's a variety of names out there. So right, but we definitely don't want to use those for transporting plates. But yeah, there's two different styles. Okay.
Excellent, thanks. All right, now again, we don't want to keep you over. We've already hit that time, but we do have more questions. So if you want to stick with us, we would love to have you hear the rest of the questions, and these will still be a part of the recording. So if lifting plates horizontally with 2 or more sheet clamps with universal eyes, can you lift more than 1 sheet at a time?
Depends what type. It all depends what type of plate clamp. I'm not sure what they mean. Lifting plate horizontally, we have horizontal plate clamps. Depending on the style of the clamp, it's different. Most of the time, the answer is no. I wouldn't. If you're, but if you have a clamp, we do have clamps that can do that, but the plates would all have to be the same size and stacked properly in order to do that. Okay. But anytime we have horizontal clamps that have jaws or teeth as well, those you would only could use for one plate at a time. So there are some things that you can lift multiple sheets. For the vertical plate clamps that I talked about in this presentation, it's always only 1 sheet at a time. So never use a vertical plate lifting clamp for more than 1 sheet. So it's always got to be 1 sheet.
Okay, perfect. Is there any application that a non-shoulder eye bolt should be used over a shouldered eye bolt?
Just for vertical lifting only. If you're always can guarantee that you're going to be vertical in line, then you can use a non-shouldered eye bolt. Other than that, I would use a shouldered eye bolt. So if there's any chance of any type of side loading whatsoever, then I would not use a non-shouldered eye bolt.
Okay. Are you saying the use of one washer is necessary with eye bolts, or that we should not stack more than one washer when using eye bolts?
I wouldn't stack more than one washer. I would just try to get, what you're trying to do is getting into the right orientation. When when you start saying stack washer, a lot of people will do that to make up a gap that maybe it's not threading down all the way into the material. So I would recommend that you shouldn't take much of a washer to get in the right orientation. So you're not talking a huge thickness there. So you can find washers of various thickness and whatever. And there's probably a calculation I can probably figure out where, hey, if you use this washer, it'll rotate it this many degrees within a circle. And so sometimes for now it'd just be trial and error, but you just use one, try a different thickness, but try to get that eye bolt as close as possible so that it's in line with the tension as I showed you in that pictorial.
Okay, really quick, on a side note, Jeff is asking if there are any free samples or anything, because Christmas is coming up. I was just going to let you all know, for any of you who don't have our rigging pocket guide, we'd be glad to send you a few copies. If you want to respond to the email that we sent, you can either do it in the Q&A pane now, give us your address and how many copies you'd like, and we'll send them to you for free. Or else you can also respond to the follow-up email I send if it's more comfortable then, and just give me your company, your name, your company address, as well as how many copies. So either one is fine. We'd love to send you some rigging pocket guides. So thank you for bringing that up, Jeff. All right, OSHA requires alloy shackles to be used for suspended personnel platforms. Is there a reason a properly rated carbon steel shackle shouldn't be used? I'm just curious why alloy. Does it have special properties that carbon doesn't?
Alloy shackles are always going to be a lot better in any type of shock loading situation. Alloy's always going to be your best, right? So any type of shock loading, it's going to react better. It's going to be stronger. It's going to have less wear. So alloy being your best over carbon. Now, shackles, you can use any grade of shackle for overhead lifting. So you start off, carbon being your low end, and Columbus McKinnon has super carbon shackles where there's alloying elements within the shackle, but we can't call it an alloy because it's not true alloy. We just add alloying elements to it. And then, so we call it a super carbon, which holds up better than a carbon in shock loading situations. And then you go up to alloy, which is your best. Alloy will also work better in cold weather situations. And if Troy is online, if he can chime in anything that I missed on that. I know Troy's one of our lead engineers for Chattanooga.
Let me allow him to speak. Just a second, Troy Raines. Troy? Let's see if that works.
Yeah, I know in the chain world we only use alloy chain, but in the shackle world you're allowed to use carbon or alloy.
Okay, Troy, are you? I just unmuted you. Can you speak? Let me see. Let me try again. There's another Troy. Hang on. Troy?
It just told me I'm unmuted.
Okay, go ahead.
It's an OSHA requirement, basically. It's more their standard than it is anything to do with the product performance. Alloy materials always outperform carbon materials, and there are some rather poor carbon shackles on the market, depending on where you get them from. But it's just kind of an OSHA thing. OSHA says it, you got to do it.
Okay. Okay, great.
I'm sorry, Troy. OSHA says you got to do what?
If OSHA says you got to have an alloy shackle for lifting people, then you have to have an alloy shackle for lifting people.
Oh yeah, I'm sorry, I maybe missed that part of the question. Good thing you caught that. Yeah, if you're lifting people, you're going to use the blend. If I'm not familiar with the personal lift, platform lift, but if it says alloy, then there's no gray area there. You have to use what OSHA tells you to do. But for general lifting, you could use any grade.
Okay. Perfect. A lot of you have been putting your addresses in. Thank you. We'd love to get those pocket guides to you. Okay, how do eye bolts and lifting clamps hold up to shock loading?
Shock loading, never good. Not good. I mean, if the clamp, you can break teeth, you can break the eye bolt from the thread. nothing really holds up that well in shock loading. That's why we just talked about like even alloy in the event a shock were to happen, alloy being your best, it may survive the shock load, being the alloy being the best, right? So we would highly recommend that you avoid shock loading altogether. Nothing works well when you shock load.
Okay, boy, the questions just keep coming in. We love to see it. So again, just hang with us if you want to hear the answers to these. Let's see, a comment came in from one of our loyal attendees. Ask Peter to address that forgings and aluminum and other types of materials can increase or decrease the depth versus normal 1.5 times diameter. Example, aluminum 2.5 times diameter for forgings. I don't know. Do you understand?
Yeah, and that's why when I talked about if you have soft material that and I wanted to put in. I didn't want to name a particular material because of the there's different strengths of every material. Where you would consult an engineer, consult a manufacturer, and they may recommend go to a 2.5 times the diameter of the thread. They have a calculation for you. They may recommend a through hole where it goes all the way through, and then they'll use heavier hex nuts and things of that to get their engagement with washers on the bottom, and they might recommend that situation is your best bet. So I just didn't want to kind of name any type of material. I kind of want to make it generic. But yeah, if your 1.5 times, if you're going into soft material, could increase beyond that. That's a good question.
Okay, very good. Just a couple more to go. Let's see. Are there any special considerations you have for eye bolts with through bolted fastening rather than threaded holes in the workpiece or concrete angle?
Yeah. Right. You still have to have you would use a heavier hex nuts. You still want to get that thread engagement that's on there, and so that it's going to hold. And I would definitely consult the manufacturer when doing that, making sure that you're doing it right. And so if that may, there might be just a situation where there are through holes that you're going to need a long, you may need a special eye bolt or a special that has a long shaft and threaded shaft on there to get it through. So it'll be a special application to do that.
Okay. I think that's it for now. Peter, if you want to just continue to the last slide. I can just speak to it quick. You speak to the training, and then I'll speak to the last side.
Yeah, we offer various times throughout the year qualified rigger workshops. So actually, I just finished one up this morning with a group that was here all week doing that, and they certified, took certification exams to certify as riggers. And a lot of this stuff is on the certification exam and how to properly use things of that nature. We have for those online, so we have some online courses for crane inspection and online chain hoist repair. Even if you took anyone can take the chain hoist repair recertification. You wouldn't be certified, but if you just want to learn more about how to fix a chain hoist and go on it, maybe some of the things wouldn't make sense to you, but it's nice to just kind of poke around and see what's out there. And then we have overhead crane operator training online as well, with some rigging involved in that. There's a little bit of rigging involved in that course too, and so it's all out there. So, as well as these safety webinars that are available on YouTube that Gisela mentioned. That so we throw a lot of information, we offer a lot of hands-on. We come on site, and really my job is to make this industry safe and make people who use products that CM sells, make them safe, to be sure that everything is in proper order.
Perfect. And just to conclude on the last slide, for any of you who are big into social media, we are all over social media. And Peter, if you can just forward. Yeah. Oh, actually, there you go. No, go back. If you want to reach Peter, if you have a specific question, go ahead, Peter, and pull up your slide. You can email him at peter.cook@cmworks.com. If you have questions you still would like to ask, you can write down his email address and ask them directly. Give you a second to do that. And then if you can go to the last slide, Peter. I just want to let you know we are on various social media, Twitter, YouTube, as I mentioned, with our videos, with our recordings. We're very active on Facebook, LinkedIn, Google+, Instagram, and then our blog. And if you go to our website, cmworks.com, in the upper right-hand corner, you will see all these icons. You can click on them, and they'll take you right to our dedicated social media pages. So connect with us there, share pictures of our products in the field, ask us questions, try to stay very engaged there, and we love to converse with you there. So on that note, thank you all for coming. If you have any further questions after now, you can feel free to respond to the email I'll send as a follow-up. Again, thank you for coming, and we wish you a great weekend.